Some time for question and answers in between each one, and then we could have some wrap up at the end if there's more questions.
You got three speakers tonight.
Some of the stuff that we do need to make sure we go over, Michigan State University Extension. We play nice with everyone, so we want to make sure that everybody feels welcome and included to anything we do here. And we do want to thank our partners, especially the speakers that are here tonight, talking about what we'll be doing. So if you guys have any topics that you're really interested in and you want to hear about next year, catch me, get my email address, and get those topics to me, because the earlier I get them, we try to line the speakers up as early as possible. Unlike this year when it was about 4 to 5 weeks ago. So, I'm going to go back here. I'm going to set Kev up. I'm going to have you introduce yourself. I'm going to put a couple microphones on you here quick.
Okay.
Sorry.
That's okay. I have 2 wins, but this is not a problem.
No, I just got to
Take your clicker.
Yep.
Thank you.
Okay. Good evening, everyone. All mic'd up now, so I forgot. Mic's at top. Yep. Well, I think the PowerPoint pulled up there. My name is Timothy Davis. I'm a research scientist with NOAA Great Lakes Environmental Research Laboratory. I study harmful algal blooms. I've been studying these phenomenon for about 11 years now. My background is that I have my bachelor's of science from Long Island University, Southampton College, out of the east end of Long Island.
Do you have your flash drive again? It's saying that the file does not.
Did it get corrupt? From there, I went on to do my dissertation work at Stony Brook University out on Long Island, and that was studying harmful algal blooms throughout the northeast United States, including Lake Champlain and Lake Erie. And then I took my first postdoc at the Australian Rivers Institute in Brisbane, Australia. I was there for 2.5 years studying harmful algal blooms in their drinking water reservoirs. I moved from Australia to Canada, where I spent about a little over a year studying, working at Environment and Climate Change Canada, and I was working throughout the Great Lakes as well as Lake Winnipeg. And then I finally ended up here at NOAA, where I've been for the past 3 years, helping to develop their harmful algal bloom monitoring program. So that's a bit about my background. Once we get my presentation going, hopefully it's not as it is. Good? Or are you still?
It's showing up on your disk. Did you make it on a Mac, or it looks like a regular PowerPoint?
It's on Mac, but that's never been an issue.
Doesn't like it.
Doesn't like it. Okay. Time out. That's right.
I wonder if I put it like on Google Drive or something like that.
Just plug in my computer to the projector.
It happens.
No, I got it.
Dongle?
Yep.
You got the right dongle?
Yep. Here we go. Sometimes it doesn't like it if you it's gonna take up a bunch of room with this thing because it's that's right.
Yeah.
I
When I was
should
what I would suggest would be 10 little ones, 35 inches long, and
yeah, I just plug in for a second so I can find my once I get the presentation open. Sure. There we go. Okay. All right. All right. I think we're back in business here. Sorry about that. Rolling. Okay. So today, obviously, I'll be discussing some of our work on Lake and Clair. This work stems from what I was doing when I was at Environmental Climate Change Canada, and it extends into what I'm doing at NOAA. The way that I have it structured is based on the audience. I don't really know what the general knowledge is on harmful algal blooms. So I wanted just to start by giving you an overview of what NOAA does in the Great Lakes from a research perspective, then move into harmful algal blooms on kind of a global and national scale, and whittle my way down into the Great Lakes and eventually Lake Erie, and then discuss some of the research we have with concerning toxins like microcystins in fish. How are we able to measure these toxins, and what's the variation that we see? So that's probably going to be of most interest to folks here tonight. Okay, so to get started, what NOAA does. Obviously, NOAA is part of National Oceanic and Atmospheric Administration with Great Lakes Regional Office. Our research is stakeholder driven, so everything we do needs to have a stakeholder focus, whether it's a product we're producing or data that can be used for management decisions. Our research model is that we conduct integrated research that gets put and eventually incorporated into these ecological models and forecasts. So we forecast everything from water levels to ice cover to harmful algal bloom development and movement. So that's our goal in the Great Lakes. We have a lot of resources at Merle, both in personnel, but also we have a fleet of vessels that we use. So a lot of the marine sanctuaries, such as Thunder Bay, we smaller runabouts that we can use to get into some of the smaller bays, Saginaw Bay, Sandusky Bay. We have our flagship Laurentian. She's mainly docked out of Muskegon, our field station in Muskegon, and has been conducting our long-term surveys of Lake Michigan for many years. We recently purchased Laurentian from the University of Michigan. Obviously, Laurentian was a university vessel. We had that on a contract for a while, but now we've finally purchased her. So she's lurls. We have our 55 footers. These are our buoy tenders. We use these to put out some of our recon buoys. So these are buoys that measure wave height, wind direction, wind speed, and you can find all of that information on Lurl's website. And then we have some of these smaller vessels, these 41 footers, and that's what we use in Lake Erie. This is what we go out to sample with every week during the bloom season, and we work with our Canadian counterparts to sample Lake St. Clair as well. So a question I get asked a lot is, we have these fisheries that are collapsing all around the world. So why is it important to study phytoplankton? It's a great question because we have these global loss of seafood species, especially in coastal regions of the oceans. Average weight of 30 inches. All of these are trending down, especially Atlantic cod. And we talk about algae because algae are important. So phytoplankton are extremely important to pretty much every aquatic environment, except for some deep hydrothermal vents, which is too deep to have phytoplankton. But they are critical in forming a healthy foundation to a food web. And when I say algae are important, I mean it not just from a nerdy scientist perspective, but it's critical for life. So they comprise about 1% of all the plant biomass on Earth, but they produce over half the oxygen we breathe. So every second breath you take, think of phytoplankton, because they're the ones that are photosynthesizing and putting oxygen into the atmosphere. They help fight rising carbon dioxide concentrations by the process of photosynthesis, right? So photosynthesis takes carbon, turns it into oxygen. They produce oxygen through photosynthesis, but they take that carbon dioxide and they turn it into carbon, and when they die, especially in the world's oceans, they sink to very deep levels of the sea, where that carbon gets sequestered for 1,000 years. So our increases in carbon dioxide concentrations in our atmosphere would be much higher if we didn't have phytoplankton taking that carbon that we're emitting to the atmosphere and pulling it into the depths of the world's oceans where it gets stored. But also, all the good things phytoplankton do, such as being the base of the food web, producing oxygen, if you get conditions where phytoplankton form these large growths that we call blooms, they can be harmful to environments. When I say harmful, I don't just mean toxic. I mean they can be harmful in terms of shading out benthic aquatic plants that are extremely important for juvenile fish to take refuge in. They can wash up on shores, they can be unsightly, they can affect home prices. And what we've seen in Lake Erie, especially with the charcoal captains, is that they tend to affect people's desire to go out on the lake because who wants to fish in the middle of a pursuit? So it can have economic effects, it can have ramifications apart from the toxicity issues that we've been seeing in the past few years. And this is just a real simple diagram of how important they are and how a change, basically this is just a real simplified food web. We have phytoplankton that can be eaten by zooplankton, that can be eaten by planktivorous fish, and then up to our commercially important fish that we like to eat. But the point here is that energy transfer through these food webs is really poor. It's about 10%. So if you have a shift in the base of your food web towards phytoplankton that aren't as healthy, that aren't as nutritious, you will ultimately impact the upper trophic levels. It's inevitable. And that's what we see when we see harmful algal blooms and we see eutrophication, water quality issues. We see impacts to these upper trophic levels. And then, obviously, primary production, these phytoplankton determine fishery yield. So if you want a healthy fishery, you need to have a healthy phytoplankton base. So one of the issues that we're seeing in Lake Michigan right now is that we don't have enough phytoplankton. So in Lake Erie, we have too much. In Lake Michigan, we don't have enough, right? So that's what we call a ligatrophication, right? So there's, because of the invasive dracaenid mussels, so the zebra and now the quagga mussels who have replaced the zebra mussels in most of the lakes, the large lakes, they have been so efficient at filtering out the phytoplankton that they're cutting out the base of the food web. So we have issues on both sides. We have unhealthy populations or we don't have enough populations. But either way, they're impacting fisheries throughout the Great Lakes. And of course, primary production. This is just another simple plot that was produced back in the early 80s, that fish landings increase with primary production, and that's pretty much true in most systems. But what is a harmful algal bloom? What is the definition of a harmful algal bloom? It's the growth of an algae to densities that can negatively impact ecosystems, like I said. But they don't just occur in freshwater. They occur pretty much in all coastal areas. So estuaries, they occur well, these estuaries that are commercially important, they occur in coastal regions. They can even occur in open oceans. So we are having dramatic impacts on our coastal and freshwater systems because of increased nutrient pollution to those regions. And just to illustrate this, prior to 1972, these dots represent the types of phytoplankton blooms and the toxins associated with them that were seen and reported in the United States. So not that many. However, post 1972, you see the range of algal blooms, and they're occurring pretty much all around the coastlines. And if you added in these freshwater blooms, the United States will be covered, because freshwater harmful algal blooms, like we see in the Great Lakes, occur in every state. But they don't just occur in every state; they occur in every continent on Earth. So, except Antarctica. But what this map demonstrates is, or this was composed by a colleague of mine, is that all of these, anywhere you see green in this world map, is where microcystis blooms, the blooms that we get in Lake Erie, have occurred, and toxins have been detected. So this is really just to show you that this is a global issue. It's not a Great Lakes issue. It's not just a Lake Erie issue. This is a global problem. But why have they gotten worse? Why have harmful algal blooms become such an issue? Well, one is because we are increasing our nutrient loading to coastal regions, to the Great Lakes, to inland water bodies. We've lost key food web predators. So who here likes to eat clams, oysters, mussels? Nobody? A couple people? Yep. Well, in order to do that, we have to harvest them. So this was a booming industry on the East Coast. In the 70s and 80s, 2 out of every 3 shellfish eaten along the East Coast of the United States came out of the south shore of Long Island. But to do that, you take away the filter feeders. So clams, bivalves, mussels, they are all filter feeders. And when you take out the filter feeders, you take out the region's ability to clean itself, which helps forming harmful algal blooms, which have, it's kind of a feedback loop where these harmful algal blooms come in. These commercially important clams and oysters don't like it, so they stop feeding and they die. So you have even less of them. Invasive species, so like the drycenid mussels in the Great Lakes, they've helped set up conditions that allow harmful algal blooms to thrive, because these zebra and quagga mussels, they don't like the type of algae that form blooms, but they like all the other types of algae. So it takes away the competition. They're filtering out the competition, giving these guys an even bigger advantage when they form. And of course, global climate change is producing a wider range for some harmful algal blooms. So we're seeing HABs in regions where we haven't seen them before, even in places like Lake Baikal. That's one of the deepest, coldest lakes on Earth, and Lake Superior. We see harmful algal blooms in these systems, places where we don't generally consider them to be eutrophied or poor waterfall. And finally, we can't ignore the fact that we're looking hard. So not all of this can be chalked up to the environmental changes and our impacts on the environment. The fact of the matter is that we have more people today looking for harmful algal blooms than we ever have in the past. So this also plays a role in the increase that we're seeing. But when we get into human health, I just wanted to run through this quickly. We have issues that stem from some of the compounds that these algae produce. And they've been producing them for millions of years. They didn't start producing them to kill us. They just produce them naturally. But when they form these dense blooms, the concentrations that they can produce in that, especially if they get filtered and accumulated into bivalves or fish, can be harmful to humans. So in the Northeast, they have two issues. They have domoic acid, which is an amnesic shellfish poisoning. If you ingest it at high enough concentrations, it can cause short-term memory loss, it can cause brain damage, and in some cases it can cause death. It has paralytic shellfish poisoning as well, these TSPs. Paralytic shellfish poisoning is essentially you can lose motor function, coordination, slurred speech, headaches, diarrhea, etc. And these all are issues because there is a thriving shellfish industry in these regions. But the shellfish accumulate these toxins, and sometimes they have to close these fisheries, which causes millions of dollars in lost revenue. Down in Florida, around the Gulf of Mexico side of Florida, so the west side of Florida, you get these Crenia brevis blooms. And these brevitoxins are the compounds that Crenia produces. And what they can do is this is a neurotoxic shellfish poisoning, very similar to paralytic shellfish poisoning in the effects. But this can also get aerosolized. So as wind blows from the ocean to the land, these toxins can get trapped in water particles that flow inland. And it can cause asthmatic symptoms. So people have had to cancel trips. They don't go to the beach. People have had to move houses. So they've had to sell their house and move further inland because they can't live in this region because they can't breathe. So major economic and human health effects. And off the west coast, this is a bloom that occurred from the Gulf of Alaska all the way down to Mexico. This happened in 2015. That is something we have never seen before. That's unprecedented. The entire west coast of the United States had an algal bloom. So when we look at Lake Erie, those are impressive. This is more impressive. And it was associated with domoic acid, that amnesic shellfish poisoning, which impacted their razor clam harvest as well as their Dungeness crab harvest. So multi-million dollars in Dungeness crab, $84 million industry had to be shut down for almost the entire length of the season. This bloom lasted for several weeks, and that had dramatic impacts on the economies of these regions. But then we get to the Great Lakes, Lake Erie. Microcystis is the organism that forms the blooms in the open waters of Lake Erie and Lake St. Clair, we'll get into. Planktothrix tends to form in the bays such as Sandusky Bay and the Maumee River. These two organisms can produce microcystins. Now, microcystins are the compounds that cause the great water crisis. And before they were known as microcystins, they were known as fast death factor. Because if you ingested them at high enough concentrations, you could potentially die very quickly. Anabeta is another organism that we see that can produce anatoxin. Anatoxin is a neurotoxin. And before it was named anatoxin, it was named very fast death factor. So these are two pretty potent toxins that can be observed in the Great Lakes. Now, before everyone freaks out, the most toxic form of microcystin is microcystin LR. And it has an LD50 of 50 micrograms per kilogram body weight. Now, I weigh about 160 pounds, which is about 70 kilograms. So if you do the math, if we have a bloom in Lake Erie that has 10 micrograms of microcystin per liter, I would have to drink thousands of liters of water to accumulate an LD50 that would be harmful to me. I would die of water poisoning long before I died of microcystin. So that's just something to put it in context. We talk about these because we need to, because they are dangerous toxins. But we have to put it in perspective that if there was a water crisis and someone had a cup of coffee, no one's going to die if you drink a cup of coffee. Okay? Especially if the concentrations we receive. And they've also inspired horror movies. So this is Alfred Hitchcock's The Birds. Remember the domoic acid I was talking about? Well, there was a suspected bird poisoning caused by domoic acid back in 1961 when Alfred Hitchcock was researching his movie, or at least the inspiration for his movie, he heard about this out in Santa Cruz, California. He called up the newspaper and said, I want all the literature you have on this. I want to use it for my movie. So calves have inspired popular culture. But when we look at this from a global perspective, harmful algal blooms impact most of the world's socio-economically important systems. So Lake Taihu in China, which serves 30 million people for drinking water, cooking water, recreation, commerce. Matilda Bay in Western Australia, the Han River in Seoul, Lake Victoria, part of the African Great Lakes, also experiences harmful algal blooms. Lake Okeechobee in Florida, and of course the Great Lakes. These are some of the world's largest, most important freshwater regions, and they are all experiencing these blooms because of greater water quality. So this is truly a global issue. And we don't have to go through this, and I'm not going to painstakingly go through this, but the point is that cyanobacteria have been on this earth for 2.5 billion years. They're very good at survival, they're very good at adapting to circumstances, and they're extremely complex organisms. So when we study them, the reason why we've been studying them for 40 years and we're still learning stuff every year is because they've been here a while. Every time we think we know something, they throw a curveball at us. So they're really complicated organisms for being millions of a meter big. And these compounds have caused and are associated with some pretty nasty disorders such as gastrointestinal disorders and cancers. And on occasion, these compounds have led to deaths in humans. For example, in hemodialysis, patients in Brazil were treated with water that was contaminated by microcystins. There's about 100 or so people that were treated, about half of them died. We've never had a human death attributed to a harmful algal, or at least microcystin poisoning in the United States. What we generally see down here is that these cyanotoxins have been linked to deaths in cattle, pets, waterfowl, and even marine mammals. So this was a recent finding. This was back in 2010. A group in California found that there was a bloom that happened in Pinto Lake in California. That bloom got washed down the river into the Monterey Bay Marine Sanctuary, where what do bivalves do? Well, they filter everything out. So they filtered, accumulated these toxins. These are southern sea otters. They eat bivalves, so they ingested these bivalves that had really high concentrations of microcystins, and they ended up dying. So that was one of the first examples where we see this continuum. We see this shift of a freshwater toxin impacting the marine environment. So then that gives us new insight into, okay, we just don't have to worry about the marine toxins. We have to worry about freshwater lakes that are connected to estuaries or marine systems. These freshwater toxins can impact marine seafood. And that's really important in places like the Chesapeake, etc., that have blooms that occur in their rivers, like the Potomac, Transquaking River, that can get flushed down and potentially accumulated into their commercially important catch. And then, of course, in the Great Lakes region, I'm sure everyone here is familiar with the Toledo water crisis, but I'm morally obligated to put this up here every time I give a talk because it's important. And what it really did was it put Great Lakes harmful algal blooms back on the national issue. Because what had happened is that those regions had seen these blooms for so many years that people just got used to it. They occur, it never really impacted many people's lives, so it's something that happened in Lake Erie. You just don't swim in Lake Erie in the summer. But when it impacted an entire city, many people in Toledo had never actually been to Lake Erie. They've never seen it, but it's impacting them. This brings it back to a national scale. But it's not the only incident. Last year, we had two major incidents. One in Lake Okeechobee. Is anyone familiar with Lake Okeechobee incident? So the state of emergency. Well, when this occurred, I went down with some colleagues from Stony Brook University for a rapid response to conduct some research. And what we found is that this bloom in Lake Okeechobee, so you have the Caloosahatchee River that flows west and the St. Lucie River that flows east. Well, it flushed down the St. Lucie River out the Indian Lagoon and around onto marine beaches. So this is a sign, this is a picture that I took. We were heading out to the Atlantic Ocean and they said, oh, you can't use this beach. There's an algal bloom that had washed up on the shore. So this bloom from Lake Okeechobee impacted, and this occurred over the 4th of July weekend. So the people that we rented our boat from, they said last year, 4th of July weekend, we did $50,000 in business. This year, $5,000. So that's an immediate economic impact. And that was one business. So multiply that by all the businesses that lost revenue. That's a huge economic impact. And then Utah Lake, last summer as well. Utah Poison Control, once this bloom, it covered about 90% of the lake. They had 138 calls from people who said that they came in contact with the water and they were reporting instances of diarrhea, vomiting, headaches, rashes, all associated with contact with algal blooms. So one of the issues that we see with reports like this is that those same issues can come from heat stroke. They can come from being out in the sun too long. So it's really hard to definitively say, yes, it was a bloom, but it gives us evidence that these blooms can, just by coming in contact with them, cause some pretty significant health effects. And for those of you who are interested, there's been a lot of talk recently about Great Lakes funding and potential cuts to Great Lakes funding. But this is a letter was signed by 47 members of Congress, bipartisan to, at that point, President-elect Trump, saying that harmful algal blooms are a national issue. They impact economies all across the country, and we respectfully request that you continue to fund research into these blooms. So this is pretty amazing, even in a time of very partisan politics, that you had a bipartisan letter coming from Congress on an issue like harmful algal blooms. So that was, for us, that was pretty interesting, and somewhat of a good sign, basically saying that, hey, this is something that affects all of the states, and it's something that needs to be continued to be funded. But when we talk about the Great Lakes, before this, who thought that algal blooms, before you saw this picture, I probably should have asked this question before, but who thought that these algal blooms were really just a Lake Erie, lower Great Lakes issue? Few people? These blooms occur in all 5 of the Great Lakes, even Lake Superior. So in 2012 and 2015, there were massive rain events around the Duluth area, which flushed into the western basin of Lake Sinclair and around the Apostle Islands. They had a very short-lived algal bloom. So even Lake Superior, one of our pristine lakes, can experience blooms. Lake Erie obviously gets most of the credit because this is where we see the largest blooms, but they occur on both sides of the border in all 5 lakes. And Lake Erie, these blooms in Lake Erie have been getting more severe over time. So when we look at these blooms in Lake Erie, we see that over time, since we started to forecast their size, they've been increasing in severity up until, pretty much we've had a couple of low years, 2012 and 2016, but overall, this trend is increasing. So this is something that we need to deal with, and that we are dealing with through some of the remediation avenue that we're trying to take with nutrients. So, yep. Great question. That's a great question. And please, I should have said this before, but if you have questions, just stop me and shout them out. I'm happy to stop talking for a while. But, so 2011 and 2015 were 2 of the largest blooms that we've ever recorded. 2015, our scale goes up to 10. 2015 was a 10.5, so it broke our scale. But what happened is, this is a precipitation difference between the spring. So the size of the bloom is based on how much phosphorus comes in from the Maumee River and then Lake Sinclair, the Thames. So what you had here in 2011 was that this was a very wet year. 2015, we got that late rain in June. Some record in June, it was a record rainfall in June. Both of those had record blooms. 2012 and 2016 were relatively dry years, so we didn't have as much phosphorus coming in. That's what caused these blooms to be smaller. So when we look at this, and if you look at climate change models for the Great Lakes, some of them predict that we're going to see more rainfall in the future. So if we don't contain any of our, if we don't do something about our nutrients, we see this rainfall and precipitation increase, we will likely see more of these larger blooms that come aboard the basin. Any other questions? That was a good question. Yeah, mainly it's non, yeah. So mainly, the question was, are the phosphorus coming in basically point or non-point? Are they from detergents or are they from, less point source, fertilizer? And mainly what they're coming in from is agriculture. Right now, it's mainly agriculture in the Maumee Basin. Back in the 60s and 70s when Lake Erie was having the same type of issues such as hypoxia and harmful algal blooms, it was mainly a point source. So that was coming more from detergents and factories. So it shifted from a point source issue, which we were able to fix with the Great Lakes Water Quality Agreement, the Clean Water Act, to a non-point source issue, which is much more difficult to control because it's not a pipe, it's not a factory, it's much more diffuse. So yeah, it's switched from point to non-point.
Does the use of filter strips help with this problem along stream beds and that to help slow down that flow into these streams?
Potentially, but that's not what we're seeing. Right? So we don't see that. A lot of it has to do with timing of when the fertilizer gets put on the ground. And we have a lot of we have the risk. We just developed a risk runoff tool to help farmers guide when they put fertilizer on their field. One, so that if it's going to rain in the next few days, they don't put fertilizer on their field so that it just doesn't get washed. It has time to absorb in. And also the way that they put fertilizer on their field. So that's what they use. But yeah, it's one of the issues is that we've taken away Lake Erie's natural filter, which was the Great Black Swamp. So we filled that in and we now farm pretty much up to the lake. That's an exaggeration, but to get the point across. The Great Black Swamp, the way that those swamps and wetlands work is that they act as gigantic sponges, so they soak up all the nutrients before they get in. This is a problem along our coasts, marine coasts as well as our freshwater coasts, that we're losing those natural sponges. So then we have to put in, alternative methods where we try to restore them, but that's a long process, and there's no way to restore the Great Black Swamp. Good question. Yes. Sewage can be. Most of our cities now have pretty good sewage treatment plants, wastewater facilities. But if you have combined sewage overflow, those can be issues. In coastal environments, for example, in Long Island, one of the most densely populated areas of our nation, I think in Suffolk County, 70% of the people are still on septic. They don't have water treatment plants. So that's a huge issue. But in Lake Erie and some of these regions, it can be, but it's not the primary issue. But it does contribute. So, St. Clair, what we're here to talk about tonight is when we look at satellite images of blooms, we generally focus on Lake Erie for very good reasons, right? They're large blooms. But what I'm going to talk about tonight is the bloom that occurs on the southern shore of Lake Erie, of Lake St. Clair. This occurs pretty much every year, but like I said in my title, it has gone for many years overlooked and understudied. We've seen it, we know it's there, but no one's ever really looked at, well, what's comprising it, what are the toxin concentrations. I know that there are blooms of Cladophora and Lingvia that occur on the eastern shore. We just don't have enough, I don't have any data, I don't know if there's much data out there on these events, but I'm going to be focusing more on the harmful algal blooms because it has direct connection to Lake Erie. So when we look at Lake St. Clair, I look at it as a mini Lake Erie. So the main hydraulic load comes from the St. Clair River, Lake Huron, and flows through into Lake Erie. But the nutrients, much like Lake Erie, it's the Maumee River. Lake St. Clair, it's the Thames River. So the Thames River supplies most of the nutrients. And the way that the hydrology in Lake St. Clair works is that the Thames River tends to flow out but then gets constrained along the southern shore. It can float this eastern shore here and down the Amherstburg Channel into Lake Erie. So we see these blooms, and we thought that they might be getting transported down into Lake Erie and maybe contributing to bloom biomass. So we wanted to check that out. So when I was at Environment Canada, what we did is we teamed up with the University of Windsor, and we did a survey. We did a spatial survey all the way down to the Canadian Coast Guard base on the Amherstburg side of the channel. And we looked at what the bloom was doing at all those points. And we did this using just regular limnological methods such as cell counts and nutrients, and we measured for toxins, but we also, I'm a geneticist, so I looked at the genetic connectivity. So I looked at how similar these blooms are to what we see in Lake Erie through genetics. And what we see is that this black line represents toxin concentrations. This is starting from that northeastern area in Lake Sinclair, going all the way down. This is at the mouth of the Clair River into Lake Erie. And what we see is that, for the most part, once you get north of the Thames, there's not a whole lot going on. But this is the Thames River, and once you get west of the Thames, you see cyanobacteria dominate, and microcystis dominates the community. So it's a microcystis bloom, same as we see in Lake Erie. And toxin concentrations sharply follow the overall concentration of microcystis, so we have a good idea that microcystis is the primary microcystis producer, same as Lake Erie. But that was one study that we published, and then Environment Canada picked up on this, and my colleagues at Environment Canada, what they're doing this year is that they're conducting a fairly intensive, I think there's 180 sites. They're going to go out 5 times this summer, and they're going to sample 180 sites for water quality throughout Lake Sinclair. You can see that they're mainly sticking to the Canadian side because they're Canadian. Not a whole lot of information on the East Coast, unfortunately, but hopefully we can add some of those sites in. But this is where the bloom generally occurs. And they'll be conducting these surveys in 2017, 18, and 19 to get an idea of how, what the spatial and temporal resolution they need to continue to monitor these blooms in Lake Sinclair. So that's a joint project between Environment and Climate Change Canada and the Ontario Ministry of Environment and Climate Change. And they're going to send us some of their data that we put up on our website. So this is little harmful algal bloom website. If you go to our homepage and click on the HABs tab, you'll see that we have real-time data for Lake Erie, Lake Sinclair, and Saginaw Bay. So you can get an idea of chlorophyll concentrations, toxin concentrations in all 3 of these systems. And this is what the page looks like. If you were to click on them, we have different water quality parameters set out, such as particulate toxins, dissolved toxins, chlorophyll, and temperature, as well as phycocyanin, which is an indication of cyanobacteria. And you can click on any one of these points, and it will tell you the exact concentration that we measured for that date, for that point. So this gives a lot of information that you can have and be updated on a weekly basis when we go out and sample. But we also use an integrated sampling method. So we just don't go out and sample from a boat. We've realized that we can't be out there all the time. So we have water quality buoys that measure water quality as well as nutrient concentration on an hourly basis. We use genetics. We try to understand how invasive species are impacting these blooms. We also use some advanced technology. This is our environmental sample processor. It's essentially a lab in a can. So what this does, this was developed at the Monterey Bay Aquarium Research Institute, and it will sample microcystins every day. So we have this deployed in Lake Erie, and what it does is it takes in a sample of water, it concentrates it, it extracts it, it analyzes it, and it sends us back the data remotely. So we can talk to it, and it can talk to us remotely. So it's kind of our graduate student in a can, but we have to pay it a fee. And then we have these products that we put out, such as the HAB Bulletin for Lake Erie. Has anyone signed up for this? The HAB Bulletin. So this comes out twice a week, and it gives an update on the status of the bloom, it gives an update on movement, and it's something that if you sign up for it, you can you'll receive emails and you can go and look at it. We're also developing one for Lake Sinclair. And this is our three-dimensional HAB tracker. So this is a short-term forecast, which I'll show you in a minute, that shows where the bloom is and where it's likely to move. Again, we're developing this for Lake Sinclair as well. And this is just what our bulletin looks like. What I wanted to point out here is that the reason why we're making a separate bulletin is that whenever we produce this bulletin and this heat map of the densities of the blooms and where it should be in 5 days, we often have Lake Sinclair, but again, we've overlooked it. It's never been that important. But now that we have this joint project with Environment and Climate Change Canada, we're going to be putting out a separate bulletin for Lake Sinclair. There we go. And this is our HAB tracker. So what we do is we take a satellite image of the lake, we convert that to a heat map of chlorophyll concentrations, and then we use a particle tracker. So we convert each cell into a particle, and then we use the physics of wind and current to push these particles horizontally and vertically through the water column. So this is what this shows. It's a 5-day tracker. So it will show where the bloom is, and it will show where that bloom should be moving, which is helpful for water treatment operators, charter boat captains, and we're going to be producing this same product for Lake Sinclair. And that also will come with this vertical mixing analysis, which shows where that biomass, where the bloom is in the water column. So all of these products will be developed for Lake Sinclair in the near future. And skip over that. And this is our ESP that we have out in Lake Erie. So I just wanted to show this short video, but basically this took about 20 years and about $20 million to produce at Monterey Bay Aquarium Research Institute. What it does is it will take in that sample, it will use heat and chemicals to lyse, so it lyses all the cells, gets all the toxins into concentration, then it moves it over, and it will conduct an array. It will conduct a toxin test. It will take a picture within a second here. And this is the data that we get. There's a little bit of post-processing, and then we can post this on our website. So it will send us that data back remotely via a modem. So we can be out there sampling every day, even when we can't get out there with the boat. And we can also reprogram this to sample more frequently if we see a large bloom event coming. But lastly, probably what's most interesting to this crowd tonight is what can microsystems do to fish? And is this a real threat to human health if we catch fish and consume fish from lakes that are impacted from harmful algal blooms? And the short answer is possibly, right? The most ambiguous answer, it's the most like government answer I can possibly give you, right? Can't say yes, can't say no, have to say possibly. And in general, state residents consume about 40 grams of fish per day, which is about 6 times national average. So we like eating fish in this region. And microcystins in these fish are taken up through diet. They can accumulate in tissue and in the organs, obviously such as the liver, since microcystin is a hepatotoxin. But here's the issue, and what makes it very tricky is that fish move, right? They swim. So even though there's a bloom, and you catch a fish in that bloom, well, how long has it been there? Has it been there 10 minutes? Has it been there for the entire season? We don't know. We also don't know how long the toxins stay in the flesh before they are degraded, because it's not like mercury. It's not covalently binded. If they will degrade, they will flush. So there's a lot that we don't understand. But basically, what we do know is that we have a very hard time measuring microcystins in fish flesh because it's a very complex matrix. So I have a colleague, his name is Dr. Greg Boyer at University of State University of New York, College of Environmental Science and Forestry in Syracuse. And what he did is he collected fish, and he's probably one of the world's premier toxin analysts. And what he did was that he took fish from Grand Lake St. Mary's and various species of fish that are caught, and he tested them. This is the detection limit. This was at detection limit, and these were positive samples. And what you see here is that Grand Lake St. Mary's is a small lake. It's enclosed, so the fish don't have anywhere to go, and blooms generally form over the entire surface. So this is a good test bed. And what we found is that microcystins are highly variable, even amongst fish caught on the same day. It's highly variable in their viscera. And some don't have any. We weren't able to measure it. And some have very low levels. So that's why I have to say it's possible that you can be exposed, but we don't have a lot of good data. Nobody has really good data on microcystin concentrations in fish flesh. It just doesn't exist. There's groups at university or the Ohio State University who are working on getting better measurements, especially in Lake Erie, but we just don't have those data. And also, some of the methods that we commonly use and that water treatment plants use, like the ELISA tests, the reason why we use them is that they're very easy, they're accurate, and they're quick. But they are inaccurate when you use them to measure toxins in fish. So if you're using ELISA kits to measure toxins in fish, you're likely overestimating the amount of toxins in your fish, because this was our fish blend. This is a fish that we know was never exposed to microcystins. Yet using this test, we saw between 2 and 5 micrograms per liter of micrograms parts per billion per kilogram in the fish blank. That shouldn't happen. And if you have samples that we injected 5.5 parts per billion into that fish and 5 parts per billion, you can see that it increases, but it overestimates the amount of toxin. So this shows that we cannot just use routine methods for monitoring toxins in fish flesh, because we will overestimate and we'll be getting false positives. What we have to use are more sophisticated techniques that take longer and are more skilled, like LCM SMS. That's much more accurate. And what Dr. Boyer did was that's what he used here, and he found that these can be highly variable and sometimes aren't even seen. So, are microcystins a potential threat? Yes, we cannot discount the fact that these toxins can accumulate. Is it hard to quantify? Absolutely, because fish move, toxins break down, and they're very hard to measure in fish flesh and fish viscera. So this is, unfortunately I can't give you more concrete answers, but with that I'm happy to answer questions to the best of my ability that you may have. Yeah? Sure, I mean, there's no reason not to. People eat them every day. You have captains that are going out and they're taking clients out and they're catching fish and they're taking them home and they're eating them. We have yet to see any issues, so I don't see any reason why you shouldn't eat them. It doesn't bother me, no. Until we see that. Let me put it this way: I don't eat shellfish. Unless it's cooked. I used to eat raw shellfish all the time. I used to eat clams when I was in college on Long Island and eat them. Won't touch them. It doesn't bother me, because a lot of the commercial walleye that are coming out of Lake Erie, that are being sold, people are eating it. We're not seeing any mass die-off, so that's potentially, but maybe not in the way that we think, right? Because some of the larger fish tend to, and I'm not a fish ecologist, we have fish ecologists in the back, so I will obviously defer to them if I say something wrong. I'm a phytoplankton ecologist, but my understanding is that, at least for the walleye, the bigger walleye tend to move towards colder waters in the Central Basin and Eastern Basin long before the blooms arise. So the fish that you're catching, even maybe in the eastern part of the Western Basin, may not be as impacted by these blooms, since these blooms on a regular year we will generally stretch to West Sister Island. Sometimes you'll get them around the Bass Islands, but they're generally not that dense out there until later in the year. It's more how are they affecting the juveniles young in the year? How are they impacting their movement, their ability to forage, and that will come down to what the fish ecologists say. But size, when it comes to mercury and mercury accumulation, yeah, older fish, larger fish get more mercury. We can't say the same thing for toxins. So that's a good question. Yes. Sure, that's a great question. So they're talking about the hypoxic zone in the Central Basin, and that hypoxic zone is getting larger, and we are working on a model to forecast that movement and size and development of that zone. But what that is that that's not produced by the summer cyanobacteria. It's produced by these winter diatom blooms. These winter diatom blooms are incredibly important for fisheries. So Lake Erie blooms in the summer and the winter, but most people don't know that. Under the ice, I've been out on icebreakers studying these blooms, and you'll break the ice and it'll look like chocolate milk. And that's all these diatoms. They bloom very dense in the winter, and they're very important for the spring zooplankton harvest, which that, you know, those large zooplankton eat these really hardy diatoms, they get eaten, and they support the fishery. So these winter blooms are extremely important. When all that biomass dies and gets transported into the Central Basin, sinks to the bottom, and what do bacteria do? Phytoplankton produce oxygen, bacteria just like us, we use oxygen and we respire, right? So when that happens, all that biomass gets pushed in the Central Basin, sinks to the bottom, the stratification occurs in the summer, so you have warmer water and cooler water, so you have all these bacteria that are heating up, they use up all the oxygen and create this gigantic dead zone. It's been getting worse because as eutrophication occurs, eutrophication just doesn't affect summer blooms, it will also affect winter blooms. So we're probably getting larger winter blooms, but we don't have a ton of information on them. Some researchers have done some work, but not a ton of work. So you do have this gigantic dead zone in the Central Basin that occurs late July, early August, and expands from there, can disrupt Cleveland water, and also if you get a rapid overturn, can produce some pretty funky smells like we saw a few years ago when people were walking around Cleveland with hazmat suits because they thought someone had a bio attack on that city. What that can do to the fish is that, you know, from what I understand, a lot of fishermen that fish Lake Erie will target that zone right above the hypoxic zone because that's where they see a lot of the bait fish and other fish congregate. So you are taking away space. How that's impacting the fishery, that's a fishery question. It's something that I can't answer. But yeah, that zone does impact where the fish will move and how they migrate. How that impacts them is a question for these guys. In the fall, so in the Western Basin, what it can do is if you have a really calm day, you get those impressive scums. When you have a big wind event, since the Western Basin is relatively shallow, it just mixes down. For the most part, it will mix the biomass around, and microcystis is well adapted to being able to float to the surface. So, yep, it'll mix it, but it doesn't necessarily impact the bloom. If the Western Basin was deeper, and you get these big wind events and push the bloom down to depth, it could cause them to become light limited and die. But because it's so shallow, as soon as it calms down, they're right back at the surface, and they're photosynthesizing and they're happy. So it will cause them to mix, but it doesn't necessarily have a negative impact unless it lasts for several days. Good question. Yes.
During your presentation, which talked about the Great Lakes area, you made very few references of Lake St. Clair. I live and I play and I fish on Lake St. Clair. And granted, some of these people go other places. But you talked a lot about Lake Erie, Lake Huron, and I do realize that water travels through. I'm interested in what's happening in Lake St. Clair. In the last slide that you showed on the toxins in the fish, were taken 5-6 years ago.
Yep.
What's happening to the fish today?
That's a good question. We don't. That's a very good question. So some of this is that it's funding dependent, right? we just can't go out. We'd love to do it all, but we can't. In Lake Sinclair, we don't have data on toxins in fish. It's something that we'd like to work up to. We would like to, be able to test as many fish as we possibly can. But it's expensive to do that, and we need to write grants in order to do that. And quite frankly, where our efforts have been focused is where the worst blooms tend to occur. And again, being a federal agency, we are focused more on the western basin because it's U.S. waters, and these blooms occur in Canadian waters. So I know it sounds petty and silly, but we work with our Canadian counterparts, and really that was the whole point of my talk, is that we don't know a whole lot about these blooms in Lake Sinclair. What I can tell you about them is from the work that I've done and the work that's being followed up on by Environmental Climate Change Canada, but we don't have any data that I know of that has measured toxins in fish. It's very difficult to do, and a lot of the historical data we are finding is wrong because we were using tests that we've always used, like those ELISA kits, but they overestimate the amount of toxins in fish. So hopefully in the future, we'll be able to collect fish and be able to run those samples properly so that we can get an idea of how diverse or how prevalent these microsystems are in fish flesh. But it's a good question, and unfortunately I don't have the answer, but the point of my presentation is that we are now looking at Lake Sinclair much more carefully because we're realizing that we've been overlooking it for so many years, focusing on Lake Erie because that's, made the national headlines, that we need to focus on Sinclair. Yep.
Aren't they talking Lake Sinclair is the bass capital of the world, the muskie capital of the world?
Absolutely.
And should people do something about what our natural resource is?
Absolutely, and that's one of the reasons why we're moving into that system. So we have been focusing historically on Saginaw Bay and other areas, realizing that Lake Sinclair is an issue, but again, it just comes down to manpower and funding, and we can only be in so many places. But now we're shifting our focus more to Lake Sinclair because we have this binational partnership with Environmental Climate Change Canada that expands our resources, expands our manpower, so we're now able to focus and divide up the workload so that it can get done. So in the next few years, we're going to be collecting a lot more information, and if I were to be invited back in 3 or 4 years, we'd probably be able to give you a much more detailed understanding of the blooms in Lake Sinclair than I am today.
I'll be here.
Okay. Yeah.
And this is going to be the last one. This is a great dialogue, but
Yeah.
You gotta realize that in Lake St. Clair, a great deal of our fish are transit. And with our work on Lake St. Clair, the work with the department, the community did downtown Mount Clemens. And we had a trap net down there, and we caught walleye 3-4 at a time in the spring. And we tagged these walleye, they were about 15 inches. And before the spring was over, 4 of those fish were caught up at the Chris Craft plant in the North Channel, and the walleye and the Clair River were going back to Lake Erie. And 2-3 years, if anybody can remember the summer around the 015 in there, you couldn't hardly catch a perch on Lake St. Clair in the summer. And for 2-3 years, we had very poor ice fishing with small fish. Yet in the winter of 15 and last winter, after having a dormant summer on the lake from Fairhaven down through here was abundant with 10, 11, 12-inch perch. They weren't raised here. Those perch came in transit. There's no way they were raised here. Our fish that are in Lake St. Clair, if you really follow it, are passing through, and they stop when it pleases them, and when they want to move, they leave. And they're going back to Lake Huron, and they're going back to Lake Erie. We used to have a run in the Thames. The Thames isn't producing walleye anymore like they did. So these fish that you catch and you worry about it, they weren't raised, and they aren't staying permanent in this way.
Yeah, that's a great point. And again, that brings to light the complexities of the data that we're collecting, because we need to, couple our toxin measurements with fish that have been tagged and tracked, so we know where they are.
We raised walleye in the Selfridge ponds, and we tagged them in the fall, and they were 9-10 inch fish by fall. Our tag showed up in New York. When we released them in the Clair River, our tag showed up in Indiana. So that was a large range. When we putting the walleye that we raised in the Clair River, when we did, they didn't reproduce in the Clair River, but they were homed in on the water. And if anybody remembers, on the last ice, the walleye were stacked up from the spillway south, thicker than the son of a gun. And when the feds came in and used their electronics, we had one walleye that was recovered 4 years in a row. And what happened, our tag fish got in with them, uncommitted fish. And we had that big walleye run. Well, the state made us quit putting them in the Clair River, and we don't have that of fish off the spillway anymore. Those were the transit fish. They weren't, they were brought in.
Sure.
They weren't raised here.
No, I think that's a great point, and it also just kind of reflects how difficult it is to relate bloom issue to fish movement, fish toxicity. All of those points you made are fantastic. I'm glad you spoke up, because that's really good information to have, and it just highlights how difficult it is to actually get good data, because we just don't know, because they move so much. It's difficult to say yes. If this was a zero, it's because they're not accumulating. It might be a zero because, like you said, they just pass through.
But we're going to take a 2-minute break to redo the technology. So don't go far, but I got a pretty loud voice, so don't make me yell at you. So just seriously, like 2 or 3 minutes, so we can get the computer switched over, and then Robin is going to be all set to go.
Watch my phone, please.
Could be you responding.
Alarm's not turned on, but we turned it on when we left, so I wanted to see how it was.
A little bit, yeah.
Crimes to the wires. Like say Claire's the redheaded stepchild. That's a pretty serious effort Environment Canada's putting into stuff. It's a huge array of things.
Well, I used to.
Hey, Dave. Hey, this is Todd, the station manager. Hey, I just wanted to confirm that someone was in there. We're going to call from the Oh, no. Oh, yeah, no worries. No, we'll let them know. Thanks, Dave. No worries. Appreciate it, man. Bye-bye. We want to try to do some water fish sampling out here.
Well, I'm glad she's on her.
Kind of plug it into that particle model you was talking about. I see a lot of them coming down the Is this the same spokesman direct that sends all that stuff in the
A couple months ago. Don't worry about it.
all the mothers love
Yeah, but it just
these guys are
We have to rate short on that, so it's on your website. And I'll take 300 minutes. And then I just want to link to the presentation. There's some good document. I'll make sure that you guys get the stamp of approval. And then, this stuff. What's your tablecloth? You want the tablecloth? So don't worry about it. But some of the other stuff, I can tell the guys to grab it. No, I just, we'll see.
About 9 inches.
Wait, we're going to be starting here in another minute or two. If you want some of the resources that Tim brought, please grab them now. This is not his first talk today, so we're going to let him drive home and get some dinner and stuff like that. So grab it while you can.
Thanks, Justin. This was really good. Yeah. Oh, it's yours. Yeah, that's right. Taxpayer funded, so take as much as you want.
If you or any college, anybody, again, we do this here.
Right. Well, just let me know. We're always, these try to bring up informational, and especially when you have groups like this, guys, they're out of there, they're using it. This is really good. I really enjoyed talking to them. This is a good perspective.
Honestly, that's more coming out of the art.
Oh, I'm sure.
They get some understanding of some of the issues.
It's probably should be a list.
No, until the guys figure out and start coming in hand.
That's right. Really?
Probably.
Okay, if we could find our way back to our seats again, grab the stuff that you want from the Noah Sea Bank table here. Because I didn't get any. All right, I'm going to turn it over to Robin, and I'm going to let her introduce herself so I don't miss any important stuff.
You just didn't want to try and say my last name.
Bingo.
So good evening, my name is Robin Bruni. I am a postdoc at the Great Lakes Science Center at the University of Toledo. I've been with the Great Lakes Science Center as a contractor of various sorts for the past 5 years. The story I'm going to tell you today is something that I've been a part of since I've been there, but there are many people, especially those sitting in that back row, that have been at this from the beginning, and so they really deserve a lot more of the credit for what I'm about to go through than myself. And just to kind of put some names to that, this effort of putting what I'm going to talk about, these large reefs, in the St. Clair and Detroit rivers, is a multi-agency effort. It's very collaborative. We have universities, we have sea grants, we have state and federal partners, and a lot of the work past the first 2 reefs is funded by the Great Lakes Restoration Initiative. Here are some of the other partners, as well as some of those that were on that previous slide, and together we formed, and with even more people, but we have a St. Clair Detroit River System initiative. That initiative started with the people that were planning these reefs, and it has now grown to not only wanting to improve spawning habitat in the system, but also just the general environmental conditions. We have people that are looking at how harmful algal blooms and nutrients, as well as coastal wetlands and other fisheries and water issues. So when I say the St. Clair Detroit River System, I just want to let everybody know where the boundaries are when I say that. So we're talking about the start of the St. Clair River. It includes the St. Clair River, Lake St. Clair, the Detroit River, and western Lake Erie. And here we are right by the Clinton River. So in the St. Clair Detroit River System, historically, fisheries was the backbone of the economy. One of the big ones was lake sturgeon. You can see from Lama in 1939 in Kansas, history of Michigan, he denotes that there were sturgeon, mackinac trout, which is lake trout, muskie, whitefish, and many other fish that were up in these waters and that were very abundant. So there was not only a very important commercial fishery for lake sturgeon in this area, but also lake whitefish. Now I didn't show the lake sturgeon, but the graph, this right here, is round weight harvested, and you can see that right around 1910, then it suddenly it goes off the map, and there's no harvest after that. And for lake sturgeon, it looks very similar. There were high catches, and then it goes down to nothing. Now for lake whitefish, there was not only a large commercial fishery, especially on the Detroit River, but they also used it for their hatcheries. So fish that were kept in those pens, they were taken out, they were stripped, and then when those eggs hatched, the larvae would then distribute it all over. So one of the reasons why we saw that decline for both whitefish and for lake sturgeon was a loss of their spawning habitat. Here we have, these are pictures of the building of the Livingstone Channel down on the Detroit River. So the building of the navigational channels required dewatering of the river, or at least those parts of the river. And you can see here, this is what it used to look like. There was a lot of this honeycomb limestone bedrock on the bottom that the fish would come up, they would spawn on their eggs, would go in between all these little spaces, they would get oxygenated, they would get cleaned by the water, the fish would hatch, then they would go down into the pier. And this is what it looked like during construction. So all of that nice rock was either blasted out, so the actual building of the channels, that rock was blasted out to make the channels deep, to get those deep draft shipping vessels in there, or it was then dumped onto other spawning habitat. Along with that, in the system, we saw a rise in industry on both sides of the border, lots of urban development. We have both Detroit and the city of Windsor in the system. Shoreline modification, the hardening of the shoreline, all the seawall that goes up and down both rivers and around a lot of Lake St. Clair, as well as the traffic. So today what we have, as a result of urbanization and development. We have a highly urbanized watershed to the system, but it is a free-flowing system, and that's very important. So a fish, a boat, a barge can get from Lake Erie, you can get all the way up to Lake Huron, doesn't need to go through any locks or dams, doesn't need to jump up anything. So that's a very positive point for our system. However, we do have many Great Lakes areas of concern. So these are the ones that are listed in the system, and they do include two of the water bodies proper, the St. Clair River and the Detroit River, but also some of those tributaries, the Clinton River, the Rouge River, and the Raisin River. So Great Lakes areas of concern, that is a designation, meaning that the aquatic environment has been degraded such that special attention needs to be brought to these areas to clean them up and help out whatever that problem is. And our work really focuses on remediating the beneficial use impairments that are associated with the degradation of fish and wildlife populations, as well as the loss of fish and wildlife habitat. So that that blasting out of all that honeycomb limestone, that was a loss of habitat. When you harden up the shoreline and you lose those wetlands, that's a loss of habitat. So those are two of the things that help to designate our rivers. Despite being areas of concern, it is still a very important fish spawning area for some of these great species. One, lake sturgeon. We have a vast population that spawns every year up near Port Huron. We also have a whole lot of walleye that come up in the Detroit River. We have lots of suckers that spawn throughout, as well as now we're getting more and more lake whitefish that are coming up into the Detroit River. So we can see that in combination with the Clean Water Act and some of the improvements that we've been helping put forward, that we are seeing our system regenerate and recover. The system is also an important larval drift corridor. So fish that spawn up in Lake Huron, like your rainbow smelt, your corridonids, which would be lake whitefish and cisco, burbot or deepwater sculpin, which are an important forage fish. They hatch up here in Lake Huron and then they travel through. And we know they at least travel through the St. Clair River. And they come down here, they grow up, they get big, or maybe they get eaten in their food for the fish that are hanging out here. And they also could possibly travel down the Detroit River. So this system is very important for the Great Lakes as a whole. So why did we build spawning lakes? Well, in 1999, there was a master's student named Caswell, who's pictured here, who put some transmitters in some sturgeon in the Detroit River. And they watched where those fish went. And what he found was that there was a whole lot that were kind of hanging out by Zug Island. And they thought maybe they're spawning there. Maybe that's why they're hanging out in this weird sort of spot. So in 2001, they put some egg mats down, and I'll show some pictures of those later on. And they got 6 lake sturgeon eggs. So now, in 2001, we have confirmed that the lake sturgeon are spawning at Zug Island, at least sometimes. They did in that year. We know that we also knew that they spawned up in Algonac, near Algonac, at what we call Metzger's Reef, which is a bunch of pile of coal cinders. And we know that they spawn up at Port Huron. So that's 3 sites. And what our researchers thought, well, maybe it's spawning habitat that's limiting this lake sturgeon population. Maybe there's somewhere in the Detroit River that we can put some suitable substrate down, replace something that was taken out, and hopefully attract the fish and they can spawn there. So what they chose was this spot right here by Belle Isle. And this was chosen because of the water flow, the depth, at where that reef would sit, the substrate underneath. So if we're going to put a bunch of rocks or other materials on the riverbed, we want to make sure that it's not going to get infilled. So that's important to have that flow. But we also want to make sure that it's not just going to sink down. So we need to make sure that the substrate that it's going on is hard paying clay, is what we like to have. So that the rocks should sit on the top and that the fish can use them. So how was it built? For this first Belle Isle reef, we used 3 different substrate types. We had this big broken limestone, and that made about 1/10 of an acre. We had rounded fieldstone that made up another 1/10 of an acre, and we had these coal cinders because we knew from up in Massinga's Reef that sturgeon like to spawn on these. So they weren't sure what they were going to like. They put one of each, and that was built using a crane and a bucket. So it was very precise, and they make what looks like postage stamps on the river. So what happened? Well, before construction, they were able to get out and do some sampling, and they caught 2 adult species. And those, I believe it was goby and rock bass in some minnow traps. We were also able to catch 1 white sucker sack fry, which is a larval fish just after it hatches. And we caught 136 walleye eggs. But they didn't get any spawning ready adults. So we know before construction, the site wasn't being used very much, or at least not a lot of detection of fish using this for spawning. However, after construction, 2 years after construction, they had 20 adult species that were captured, 10 of which were spawning ready adults. We caught 10 different species that were hatched out from the eggs. So again, we sampled for the eggs, we collected them, and we brought them back to our lab, and we let them hatch up. And then we identified what those larvae were. We caught 10 different species based on what was deposited on these reefs. And we had 14 species that were native, that were in that spawning ready condition or that hatched out. So these small spawning reefs that we put up at Belle Isle were being used by native species that we wanted to help in our system. However, we didn't get any evidence of lake sturgeon spawning. So we say that it worked. Although we didn't get any lake sturgeon, we definitely had other valuable species that used these reefs. We had walleye that used them, we had whitefish that used them, we had suckers that used them. So we'll just make the next one bigger. It also showed that we could have successful collaborations. That big picture when I first showed you with all those different agency logos, a lot of them were still there for that first one. And it also helped us identify future needs for future reefs. And I will say that that this list here, we've been learning as we go. So I'm going to go through what we do now, 15 years later, but that isn't necessarily what we did at the second reef. But we're learning as we go to make each one better, both for us and for the fish. So we knew that we needed to get maybe a better way of doing some site selection to make sure that we were targeting the lake sturgeon and lake whitefish. Do a little bit more, do a more rounded and complete physical assessment of where we were thinking of placing these reefs, and we got much more in depth in our biological assessments. So, since 2004, we've had 8 different reef construction events, I'll say, that put over, I think it's
16.
Thank you. 16 and a half acres of reef material at the bottom of the St. Clair and the Detroit River. We have 2 reef sites that we actually have expanded on, so that's why I say different reef constructions. Belle Isle, which was first built in 2004, was expanded in 2016, and so now there's over 4 acres of spawning habitat up here at the northeast corner of Belle Isle. Also, Fighting Island, which is over on the Canadian side, had a reef that was first put in that was a little less than an acre in 2008, and then in 2013, seeing the success that they were having with part of it, they decided to put a nice big expansion on the back end of it. But now we have reefs. We have 3 reefs that we have put in the St. Clair River, and we have what's going to be 4 sites down in the Detroit River. The Fort Wayne reef, we are scheduled to put that in sometime this year. Oh, it's by Algonac.
At the entrance of
I can show you I will show you an aerial video.
It's at the entrance of the middle channel.
No.
Let me hold your head underwater.
There's a boat channel that you can
I
line
can
up
show
on.
you that one too.
There's a boat channel you can line up
These
on.
ones I can show you. like a nice aerial view.
The middle channel one's easy to find with aerial photo. There's a channel that lines up beautifully right with the head of it.
Nice.
That's a great chart.
So, so these three right here, I've highlighted these because I'm going to show some of the actual biological responses and trends in the fish that we caught. And so I just wanted to bring your attention to when I talk about hard sight, I'm talking about up here by East China. The Point on Shen's Reef is right after the bend by Algonac, and the Middle Channel Reef is right after the Middle North Channel split in the Middle Channel. So reef site selection. So two of our scientists, they made a model, and this model combines different pieces of information that we thought we want to make sure that we have the best sites that overlap as many of these as possible. So one, were these sites historically used by lake sturgeon and lake whitefish? Is it out of the shipping lane? We don't want to put a bunch of rock in the shipping lane that might get then dredged up later. What's the water velocity? Both sturgeon and whitefish, their eggs need a certain velocity in order to, again, keep them oxygenated and hatch them and develop them properly. Water depth, both those species, they like certain depths, but also we wanted to limit the plant growth that happened on this material that we're putting in the river. What's the current use of the area? So this is a big one for things like an underground cable. You don't want to put a reef where there's a cable going in there. Is there a ferry or some other very common use that this might conflict with? We didn't want our reefs to conflict with anything else that's already happening in the area. As well as what's the current habitat conditions. We're going to go in and we're going to put this rock down. We don't want to put it on top of rock that's already there. We want to put it down in an area that can hold the reef and where it's missing. So what that gave us was these two maps for our rivers. So what you'll want to notice is that these blue and this really light blue color, those are the locations that scored out the highest. Taking those 6 considerations, these ones will probably be the best. And those that have that red color that doesn't show up too well. But you'll see up here, we have it right there, that's where our hiding island is. Right here, which our grassy island site is not far from this little circle. And then here's Port Huron that we know we have a very large flying population yet. Right here, Hart's Light is right in here. Where our Algonac one is. I'm sorry, it's by East China. There's not like a city right next to it. Right?
Yeah, it's almost crossing like where the river district hospital would be. You went straight over to the river.
So for the physical monitoring, so this is where we go out to that site. So we use the site selection map first, and then we decide, all right, we're going to check out a couple of these sites. Then we go out and we do some physical monitoring. We look at the bathymetry and the depth contours, so that we know, again, what we're dealing with. And a big one, again, is making sure that it's deep enough that it's not just going to become covered in macroplates. We also look at the substrate. So we want to limit infilling with sediments. There are a couple of our reefs that we've had infill with sediments. So now as we move forward, we really look at that. We look to see, we use things like site scan sonar, in this dot right here, which is where a sample was taken, and then this is what we have. So we want to know, are there big sand loads that are moving down the system that then will make it down and cover up our reef, and then it's not useful anymore. Right here, this is a core that was taken at Fighting Island. Here you see the gravel and sand, and then you have that nice hard pan clay that's going to hold our reef up at the top and it won't sink down. We also do post-construction assessment with our divers. And if we're lucky, these were taken at Middle Channel. If we're lucky, you even see sturgeon when you're going out to make sure that the rock is put where it's supposed to. Does anything look too hilly? And when our divers went out, sturgeon had already found it. I mean, they were still building it. Sturgeon found it, and they already had laid eggs. So we knew that if they were put in the right spot, the fish we were looking for could find them. One more thing that we've done with our past 3 reefs is we go out and we really look at the water velocity and the flow direction, again, in those potential reef sites. So this is from down in the Detroit River by Grassy Island, just a little northeast of Grassy Island. There's this big hash box, and that was what was going to be considered. So somewhere in here, is there a spot where we can stick 4 acres of rock that's not going to get infilled and that isn't going to cause any other problems? So they went out, they looked at this, or they got the flows as well as the velocities, and for this map, the warmer colors, the red and the yellow, is a higher velocity, and the blue color is a lower velocity, or what would make a depositional zone. And you have that right here in this corner, that big blue spot. We don't want to put a reef there. That's where it'll get infilled. So based on our blue velocity, along with all those other things that we talked about, this big rectangle is where we ended up putting the reef for Grassy Islands. So for our biological monitoring, now we look at egg deposition. We look at egg deposition not only at the reefs, we look at it above, on the reef, as well as below, and at other sites throughout the system, so that we know if walleye is going up and down everywhere, or is it just going up, say, at our reef, which would be really great. We also go out and collect larval fish. We collect, other sides of that. We go out and collect juvenile fishes, and also adult fish. That's actually a diver hugging a sturgeon on that day when they went out and were looking at the channel. Yeah, it's a little hard to see, but yeah, they were up and close and personal with them. These up here are some lake whitefish eggs that we captured. This is a little juvenile lake sturgeon that was captured for the first time downstream of Fighting Island. And there's a pike, I believe, by Middle Shore. So for the egg deposition, how we look at that is we take basically, this is what the material looks like up close. It's a furnace filter. We wrap it around some steel, and we put it down on the bottom of the river. And we check it once a week. We get out there as soon as we can in the spring, so we can get the walleye spawn, and we go until after the lake sturgeon are done. And then we go out again in the fall so we can get the whitefish, and go until it ices over. So we pick them up once a week, we inspect them, and then we pick off all of the eggs. Most of the time now, our crew is pretty experienced, and we're able to identify the eggs right there in the field, but we also do bring some back and we hatch them out and identify them using their larvae as well. And what we found is that our reefs are being used by a variety of species for spawning. Walleye, suckers, lake sturgeon, whitefish, trout perch, as well as others. We know that mud puppies, for instance, put their eggs in there sometimes. We have brown goby that use them as a cave, because they're cave spawners. They get in there and then we pick them out. So for lake whitefish, this is just showing where we've gotten whitefish eggs in the system. So over here for the Detroit River, we can see that we get whitefish eggs, or have gotten them, pretty much throughout the river. But we've gotten them a lot up there at our Belle Isle Reef. This is our Fighting Island Reef. This spot is our Grassy Island Reef. And then through those navigational channels. Over here for the St. Clair River, you'll see that there is a little spot that's right there by that Hart's-Light East China Reef. But those dots were only collected in 2014 and 2015. The 2014 was just downstream of where we ended up putting the reef. So that was good. We picked a good spot. They already like to be there. And the 2015, I believe, is right on the reef. Now, for lake sturgeon, really has shown us that these can be a success. For all the reefs that are listed down on the bottom, for all of our reefs except for that first Belle Isle reef, we've collected lake sturgeon eggs the year after it was soon as we put that reef in, they are on it the next year. The N at the top is the number of years sampled. So for that Belle Isle, that first Belle Isle reef, we've sampled those reefs now for 10 years and we still haven't caught a lake sturgeon egg. But at all the other ones, even Grassy Islands only had 1 year sampled, and we get lake sturgeon eggs right away. So this is really great and encouraging.
What about the new Isle?
We have it. So the new Belle Isle reef was put in last fall, and the spring is the first sampling for it. So we have egg nets. The new set is actually sort of a reef complex. It's not one big reef like at all the other ones. It's 3 separate ones. And it's not lake sturgeon spawning season yet, so we'll see. Hopefully they find it this time. So for our larval fishes that drift up in the water column, we sample them as soon as we can get out, March until July, and we use these bongo nets. And those, we sample things like our whitefish and our walleye with those, as well as we sample yellow perch, and anything else that we get in there, but we're we're definitely targeting that whitefish. We want to know how many whitefish are coming out of the rivers, especially the Clair River, as well as in the Grove. Now, specifically to the reefs, we also do D-frame sampling. So this is a diagram of what the D-frames look like. It looks like a D, and it sits down on the bottom of the river. And we have sites that are upstream of the reef, and we have sites that are downstream of the reef. And so this sort of the upstream sites let us know sort of what's ambient drifting down at the bottom, and the downstream ones gives a better idea of what's maybe drifting directly off of our reefs. So these nets are fish at night, and they are fished really around the lake sturgeon drift. We really want to know, because lake sturgeon are species of interest if they're coming off of the reefs, especially since we know that they've been spawning there. So the middle May, that happens on the Detroit River because they spawn first down there. But up on the St. Clair River, we don't start doing night drift until in the middle of June. So I want to show some results. So here, for Hart's Light, this is all the fish that we caught in our D-frame nets. And it's showing you by date, downstream versus upstream. So what's really exciting for this one is that the lake sturgeon, which is this dark red color, that's hard to see, but it's here, here, and here. So we got lots of lake sturgeon downstream of the Hart's Light Reef. So we believe those are drifting right off of our reef, and that's great. So those eggs were laid down there and they were hatched. We also got, up at Hart's Light, a lot of burbot. So a lot of those transient species that I talked about coming from Lake Huron are coming through our system, and we're seeing a lot of them. The sprites, blue color, that's all right here. We also have a lot of suckers drifting through our system. It's light gray colors. And also the rainbow smelt, which is a tealish color. So that's from Hart's Light. And there's a lot of colors, but that's because we get a lot of species. And again, that's a good thing. That's showing us that a lot of different fish can reproduce or at least, move through our system. Down at the Algonac Reef, it has a longer sampling. Maybe we're able to sample up through July, into July. We see similar trends. We see our suckers. We see our suckers down there, but we see a lot of rainbow smelt, that teal color. We're getting a lot of rainbow smelt, both upstream and downstream of that rainbow. They're larvae, so they're like so they're just hatched. Yep. No, these are all fish that are just hatched. They're still just little babies. But we're also getting a lot of gobies at that Point au Chien, that Algonac Reef. So goby are really liking that reef. And their larvae are very much drifting around in that area. But we also do get, here's our lake sturgeon. So we are still getting lake sturgeon on the Algonac Reef. Now, look, just to kind of zoom in on that lake sturgeon, again, this is just upstream and downstream. This is our catch per effort. So generally, how many are we getting per hour fish? For hard slate, you can see that downstream we're getting more. That's great. They're likely drifting off of our reef. At Point Ashton, we caught more upstream than downstream, but we caught them in both areas. So, and that's not terribly surprising because we know they spawned at hard slate, and we also know that they're spawning up at Port Huron, that there's fish that we're going to catch upstream of our reef. And then down at Middle Channel, so these are the results when we monitored that reef right after it was built in 2012. We got lots of lake sturgeon both upstream and downstream of that reef as well. So for the juvenile and adult fishes, those are sampled with set lines. Over here you see a sturgeon coming up on a set line. They also attach minnow traps now to the ends of those sets. So we kind of get to, we aim to sample those smaller benthic and juvenile fish at the same time they're sampling those big fish, as well as the gill nets, which do catch some lake sturgeon, but really are getting those suckers and walleye and other fish that are spawning in the area. So for some quick results on fish captured right around our reefs that we've put in. So here we have our reefs and the years that they were sampled. But what I really want you to look at is this new species post-construction. So post-construction, we're seeing log perch at 2 of our reefs, and that's a really good indicator because they're important for mussels. Also, we're getting burbot now at 2 of our reefs that we weren't getting before, and redwars, which are somewhat sensitive species. And so when we're catching more of them, that means that our system is improving. As well as channel catfish, gizzard shad, and they caught adult rainbow smelt. But what's more interesting is that this North Channel control site that is not associated with the reef, but has been sampled at the same time as all of these other reefs that have been sampled, they haven't gotten any new species since 2011. And that was before any of these reefs were put in. So nothing is changing just at the North Channel, but at our reef sites, we are attracting new species. So these results combined with what we're finding is that we know that native fishes and fish that we're interested in are using our reefs for spawning, for possible refuge, for forage. So they're being used. To look at some of the gillnet data, they've looked at what they're following as their indicator species, the walleye, white sucker, and redwars, and this is data from the Fish and Wildlife Service. Their post-assessment catch per efforts, how many they're catching per gillnet set, has generally been higher post-assessment, and that's here in these red bars, even if that difference wasn't significant. But if you look comparing the pre-assessment, which is the blue, to that post-assessment, which is the red, you can see that they are, at all the reef sites, moving up post-assessment. And we do find lake sturgeon on our reefs. This is at the Fighting Island Reef. But because of how long lived it is, and we know that it's likely not the same individuals, we don't have, they haven't found the way that they want to show that data yet. But we are catching lake sturgeon, obviously, and they are spawning. So in summary, sort of for this part, our artificial reefs are showing immediate success. We have lots of species using them, sturgeon, whitefish, suckers, walleye, as well as others. They're spawning on them. We have lots of species that are drifting off of them or by them. And our monitoring is showing that there is continued use by many other fish species throughout the year. And these, all of these reef projects are part of the projects that are listed that are needed to be completed in order to delist the beneficial use impairments associated with the fish and wildlife populations and that loss of habitat in the St. Clair and the Detroit River areas of concern. So all of this goes towards delisting that, and especially for the St. Clair River, all of those habitat projects have been done. and that's being written up. And so hopefully soon, in the next year or two, or sooner, that the St. Clair River will be able to be delisted or redesignated as no longer an area of concern. If I have time, okay. There's also other habitat projects that have been going on in the St. Clair River specifically that our group, our lab, has been monitoring for the past 2 years. So at 5 sites in the St. Clair River, mostly the municipalities or other organizations had put in to get grant funds to make habitat improvements along the shorelines. So we have three habitat improvements that were up in near Fort Huron. We have one in Marysville, and we have one in Cultureville. Thank you. So at the very north, the Fort Huron north site, there's 93 meters or about a football field long spot of shoreline that where the seawall was removed and mixed rock and native and shrub grasses were planted on the bank. A little bit south of that, they had 150 meters of shoreline that were softened. Again, the seawall was taken out and large woody debris was added. Down here, these are aftershocks. The Blue Water River Walk had 1,100 meters of shoreline that was softened, so that's over half a mile that was softened, as well as having that river walk incorporated into it. And the Friends of the St. Clair River go through and they really upkeep that river walk nicely. I saw a presentation on it last week. So. Down in Marysville, about a quarter mile of shoreline was softened. They took out the wall and they put in mixed rock, large woody debris, and they put a lot of plantings along there. And in Toxins, 152 meters of the shoreline was softened. So they took it out and they put in this nice little walkway, or gentle slope, I guess, into this area that also has a rock outing to provide some refuge for smaller fishes. So what we did is we came in after all, so we were not a part of making these great habitat improvements. We were a part of seeing what fish use them. So we went out there and we sampled for larvae, we sampled for juveniles, and we sampled for adults. So all the life stages and eggs, as well as eggs. So all the life stages we tried to get out there and see what was using it throughout the year. So just some quick overviews of that. Species that were found at all of the sites, both the restored sites as well as there were a couple control sites that were also used, are smallmouth bass, yellow perch, and common mud puppy, which is a species of special concern now in Michigan, who loves to eat gobies. So put them back in the water if you catch any of them. Those were found at all sites. And there were a few sites where we found, again, some of those sensitive species that when you start to catch them, that's a real indication that the aquatic environment is improving. And it's getting better for those species, including the pug-nosed minnow, the river redhorse over here, and the northern mad tom. Here's just a few more shots of some other fish that we got. We got a couple of trout right there. There's a nice picture of our mud puppy and our pug-nosed minnow, and some rainbow darters. So the habitats, again, that were restored, they were used by multiple life stages and multiple species. All of these different sites were. And continued assessment will help us to determine that those habitat improvements, the performance, how long it's going to last, how much upkeep would need to happen for it. And these projects were also part of that list of projects that were needed to be done in order to remove the loss of fish and wildlife habitat for the St. Clair River eels. And with that, I'll take any questions. And you wanted to see, but first somebody wanted to see what the middle channel was. I think that's right, it's right here. So this is the middle channel reef.
There's a Corps of Engineers docking
Yep.
station on
Yeah.
Well, that's the docking station.
Yep. That would be, Todd might be able to tell you that one.
That one's had some infilling, so the part on the northwestern shoreline there, you can still see.
And then this one isn't quite as far as I thought it would be. So I apologize. I used a different slide for this. I don't know if that will help you find the alganet reef.
Yeah, right off the seafarers.
Okay. Yeah, I know it's near that. We had to move the site down. They're not far off the shore.
Right where the bank.
Yeah, it's right. Yeah, so there's the contour where it gets down to the bottom, and then it's like right there. We have raised, in some of our post assessments, there have been dead zebra mussel shells. I don't believe any of our reefs have been covered by live zebra mussels. I know we have the shells on there, but I don't think we have live zebra mussels that are on there. Our big problem is the infilling. The middle channel reef, which is built across the channel, had a lot of it filled in with sand, and that also happened over at the Fighting Island Reef. The first one was put again across the channel, and the east half of it was filled in from the sediment coming down from the James River. But the other half of it is still clean and useful.
Okay, if there are no more questions, I'd like to thank Robin. We are going to take another, just a 2 or 3 minute break. We're pretty close to on time. We're a little behind, so we're going to get the PowerPoint presentation switched over. So go ahead, stretch your legs, and listen for my voice again.
Seeing all that burbot come in the area is kind of cool.
It is very cool. Yeah, they're neat fish.
They're good eating too.
Yep. We got one last year, excursion fishing, but it was only like that long.
Yeah. Are they a June or a May spawner mainly? There was a guy that caught one down on the wall in downtown Detroit just the other day.
Ed Roseman got to ask about when they spawn.
If you go out and fish, you know, if there's enough of them getting in the area to spawn, and you're seeing enough larvae, well, maybe there's enough to actually go out and hunt.
Yeah.
And since there's not a full season, I don't know.
Well,
no size limit for July 10. I mean,
we've always had lots of larvae drift down on Lake Huron.
yeah.
All the way through the system. But we haven't seen adults or even juveniles show up.
It'd be nice to see what they do that. You know, we had a customer catching one in the stove. Really? Yeah, about 20 inches.
No.
Huh. It's a little beat up looking, but it was in spill.
Yeah.
So it's kind of cool to see that.
Tell me you weren't coming.
Who told you that?
I thought you did when I saw you over in Ypsilanti at the.
Really?
Lake meeting.
I think I said I didn't know if I was going to
Oh.
be there. I was going to go to the Lake Erie meeting and see the Lake St. Clair portion of it. You know, the last day there. But that didn't work out. I couldn't make it. So then, like, oh, this is closer actually. So this was better.
Before I forget, if you want notifications of this happening next year, I do have a sign-in sheet, and then also shows the need to have these. So Michigan State doesn't get enough people signing up, I'll be like, you can't do this. That's my part of it. I don't know how long.
I'm going to have to text tomorrow. I'm like, I said, what if I don't? Yeah, when's bourbon spawn?
Anywhere from late fall through early spring.
Oh, right through the winter.
So we try to do it, don't matter with some kind of index starting March.
And are you still looking for samples?
Yeah.
Do I have any hot corners? Sure. We had one.
We actually want to put some transmitters on.
We had one student fishing this fall and let it go.
When Jim was with you, right?
Yeah. And later he's like, I think I'd want that fish.
We put our river traps out early in the spring and we started catching them right away. And then I'm like, the fish commission meetings, I'm like, hey, you guys got any extra walleye transmitters? We're going to do tags on
Of course.
We even have tags ready back at the lab.
Yeah. As soon as you're ready.
That's pretty weird. We see the larvae like early in the spring until August.
Yeah.
They do the same thing.
Because there's always been, even, when they sampled years ago, they always got bourbon hearts coming through. Adults sampling. Or even those little juveniles.
That's a pretty good size.
Yeah. No.
They're going to invite you in to see.
No, they don't want me involved in that.
Mike, can I use the pretty picture of you holding the fish next time? I almost took it off of Jim's Facebook, and then I was like, oh, I don't know if it's really there.
Hey, we can start the motion on the back.
It's all out there all over the place. Oh yeah. Isn't that great? Yeah. I put it in my office right after I left.
Willing to mile away? Oh, nice. I miss you, you're missed.
Okay, so I'm going to turn it over to the DNR folks. You guys can go ahead and introduce yourself. They are going to go without a mic, so if you have a problem hearing them, move closer.
And we'll try to speak up too, so thanks, Justin. My name's Todd Woods. I'm with Michigan DNR Fisheries Division. I'm the research manager for Lake Huron and Lake Erie. I work out of the Lake St. Clair Research Station over here in the South River Road. My colleague and I, Dr. Jan Hesnauer, are going to be sharing this presentation this evening. I'm going to cover the first parts, which are kind of an update of our annual survey activities, and then Jan is going to do a fishery status update for you. I got to give Jan credit because he did the lion's share of the work on putting this whole presentation together, so thanks, Jan. First thing I want to mention is our annual status report. Typically, we have this done by this time of year, but we've had some staffing changes, we had retirement, and we haven't been able to finish our status report yet this year, so we're working on this now. We hope to have that out as soon as possible, but keep tabs on our webpage, because when we get this done, it'll be posted to our station webpage. The other thing I wanted to address right away, and many of you may be aware, you may have seen some of the news reports over the last couple of days, or even if you've been out fishing, is we're experiencing gizzard shad die-off right now. We've had calls probably since mid-March or so, really when the weather started fluctuating. We've got some of those warm spikes and drop in the temperatures of shad dying out. So this isn't unprecedented for Lake St. Clair. It's something that we've seen happen a few times in the past decade. I know there was a rather large dive around 2006. We saw it again around 2011, and we're seeing it again this year. We don't have really good data that shows shad abundance on our side of the lake, so we went to our partners in Ontario in the Ministry of Natural Resources and Forestry, and they do a seine survey every year that allows them to index gizzard shad abundance. So this just gives you an idea of the year class strength of gizzard shad in the system. And what we saw in the past 2 years is we've got some, if you ignore this year class right here in 2013, we've had some pretty large year classes here the past couple of years. So a couple things happen. Gizzard shad are really sensitive to environmental fluctuations. There's a lot of shad in the system right now. And this die-off is happening at a time of the year when the fish's energy reserves are low. So that makes them naturally susceptible to dying out. The other issue is when their energy reserves are down, they're more vulnerable to disease. And we know that there is a virus in the system that's been here for over a decade, VHS, some of you may have heard of that. When those fish are depleted, when their energy reserves are depleted, that makes them more susceptible to disease too, so that disease may be at play. What we have done over the past couple of weeks is we've collected samples, some from some canals up by Fairhaven. This week we were down in St. Clair Shores collecting some samples, and we're at the north end of the lake collecting some samples too. What we do is we take these samples, we send them over to the Fish and Health Lab at MSU, and they run a litany of tests on them to look at what diseases might be present. So it'll be a little while before those results are out, but this is something that we're hearing a lot of concern on. We want to go out and be proactive and take a look at what might be behind that dive. So nothing that's uncommon. We're doing our best to stay on top of it and monitor it and track what's going on. So I want to touch on our annual student surveys that we do every year. 2016 was a little bit unique because we had some issues with our research vessel, the Channel Cat, big blue boat that you see parked out in front of our facility. Last year we had a repower. We had 2 new engines put in it, so it was out of the water for a good part of the spring, and we weren't able to do some of our standard fisheries assessments. So we weren't able to do our spring trapment survey in Anchor Bay. We weren't able to run our spring trawls in Anchor Bay. But we were able to get out and do some other things with some of our other vessels that we had that time. So I want to talk a little bit about some smallmouth bass tagging that we did, our annual set line survey. Like I said, we weren't able to get our spring trawls in. We added a new nearshore electrofishing survey last year. And then we were fortunate enough to have the first creel survey done within Lake St. Clair in well over a decade. So Jan is going to touch on some of the results from that too. So kicking off with our smallmouth bass tagging, typically we tag smallmouth bass in the spring in our trapment survey up in Anchor Bay. However, we didn't do that survey last year, so we used the opportunity to kind of expand our tagging down to the mile rates here. So what we did was we took our new electrofishing vessel down there right during the typical time when we're trap netting, which is late April, mid-May. And we shocked about 500 smallmouth bass in that area, and we put jaw tags on. The idea is here is we want to learn more about where these different smallmouth bass are moving. So if you look at our whole data set, these are all of our Anchor Bay tag returns from our trap net survey. And what you can see is for the most part, these fish are homebodies. They like to stay around Anchor Bay. You get some fish that move up into the St. Clair River later in the year. Fewer fish that move down into the Detroit River, and this fish right here took a ride in a live well on the, I think it was Whitmore Lake. We had one of our tags. There's only one way that fish got over to Whitmore Lake. So
could have made it up some creeks.
We know there's a very popular smallmouth bass fishery down around the Mile right in here. Yeah, we didn't have the ability previously to go down there and collect fish and put tags in. So now that we've got that new electrofishing vessel, we can do that. So we tagged 500 and some fish. We had a few tag returns come in last year, and similar to what we see up in Anchor Bay, most of the tag returns were focused around the area where we tagged those fish. So Early indications suggest that those fish might be home bodies too, but as we get out there each year and put more tags in and monitor where those returns are at, we'll have a better idea of that behavior. We are going to run our trap net survey this spring in Anchor Bay, but on the days when we're not lifting trap nets, we're going to have our shocking boat down on the mile roads, and we're going to be tagging fish down there too. So basically the way it works is there's a generator back here and a control box and console, and it sends a pulse DC current out through the water. So the electricity is most intense around the probes, and the way that it works with fish is that the current actually draws them in the boat. So if you get fish that are out here in the periphery, you will see them trying to swim away, and they can't, they'll get sucked right into the current. So it's typically most intense around the booms and really definitely. So we're most effective at max in like 5 to 6 feet of water. You really can't go down too far deeper. You can in some cases, depending on the conductivity of the water and how we adjust the current, but it's typically most intense in the, I will say 3 feet off of each side of the boat and in front and around the booms there.
Yeah.
Yeah, so we had the boat out on Black Creek today. We weren't shocking. We had a report of a fish kill in there, and we wanted to get in there to see what was going on. And it was, I think, related to the shadow. So the other work that we do, that we were able to do this year was our standard set line survey for lake sturgeon in the North Channel of the St. Clair River. This is a survey that we've done every year since 1997. This year we captured 174 total lake sturgeon, ranging in size from 21 to 71 inches, and we had 54 individuals that were recaptures, that were fish that we had tagged in previous years, and then caught again this year. One of the fun things that we got to do this year for us was we were able to get our governor out of the boat. So this was actually the first time that we have ever had a governor out on one of our research vessels, and it was Governor Snyder's first time out on Lake St. Clair. So we think we're fortunate that we get to interact with our elected officials and show them the awesome natural resources that we have out there in our backyard and create that awareness for them. So it's pretty cool to have the governor out on the boat. That's the first time that that's ever happened on one of our research vessels. And it was us. So they had a fun day. He got dirty, got his hands dirty, lifted set lines, helped us work up fish, and it was kind of a neat event. One of the things that we do when we are fishing our set lines for lake sturgeon in the North Channel is we also deploy minnow traps on the end of our set lines. And what we do there is we target the species that Robin mentioned. It's an endangered species in both Michigan and Ontario, and it's called the northern madtom. It's a little member of the catfish family. And what we have done over the years is we have tried to assess northern madtom abundance with those minnow traps. Well, over time we've used different baits, trying to get more madtoms in the traps. And this year we hit on night crawlers in bags with inside the minnow traps. And we had the highest catch rates we've ever observed. We had just about 300 madtoms that we handled this past year in 2016, which I think is probably more than we have handled in all the years previously that we have done this. So by doing that, by increasing our catch rates, we're able to collect some neat biological information on this that hasn't been collected before. Just basic info like lengths and weights and trying to look at the relationship between those. The reason that we're interested in these is they're not only an endangered species, but they're kind of like the canary in the coal mine. They have really unique habitat requirements. They're sensitive, very rare, and this helps us gauge what's going on not only within the community, the fish community, but kind of the ecosystem as a whole too. One of the new projects that we've added, because we have that new electrofishing boat added to our fleet, is a nearshore electrofishing survey that we do in the fall. This is a survey that Janet designed. And basically what we're doing is we're hitting the nearshore areas from Fairhaven all the way down to the Clair River. And the idea here is to get in and sample some of the nearshore communities that we typically weren't working with in some of our other surveys, like our trap net survey and our trawl survey. Typically with those surveys, we're working outside of the 10-foot contour. We know there's a lot of habitat and important fisheries within that 10-foot contour, so we're able to get out and sample those with the electrofishing vessel. And what we found was really a neat suite of different fish species. Pretty remarkable catches of a lot of the different species that inhabit the nearshore. Altogether, we had 36 unique species. We handled over 3,400 individual fish. We found largemouth bass, yellow perch, and brook silversides at all 13 of the stations that we sampled. Emerald shiners, brook silversides, and yellow perch were the most numerically dominant species that we had in the survey. This is our first year doing it. We plan to add that to our annual suite of services. The other thing that I touched on was this was the first year since I think 2002 to 2005 since we've had a creel survey on Lake St. Clair. Has anybody ever spoken to a creel clerk before when you're out fishing? So okay, cool.
Many times.
Basically, what our survey creel clerks do is it's a program that allows us to estimate how much effort is occurring in a water body, what people are targeting, what they're catching, and what they're harvesting. Obviously, we don't have enough people to have someone at every launch site every day of the year. So what we do is we focus on the open water fisheries typically, so from April through the end of October. And our clerks follow a design that has them in different places at different times. So we can get a representative sample of what's going on. That allows us to expand the information over the entire season and across all the survey sites. So when you see a creel clerk, they might ask you, hey, can I interview you about what you were fishing for today? If you say yes, they'll ask you about what you caught, what you were targeting, what you harvested, and so on. And then we also have clerks that are either counting trailers or boats that are out on the water, or sometimes we use airplane flights to count the boats that are out there. What this does is it allows us to get a total estimate of how many people are fishing throughout the season. And then we can look at things like catch rates, like how many fish people are catching per each hour of fishing, and then compare that to previous years. 2016, we had 2 creel clerks that covered all of the public access sites in the Michigan waters of Lake St. Clair. Like I said, it was the first creel estimate in over a decade. And this year is really exciting. We're going to be pairing with the Ontario Ministry of Natural Resources and Forestry to do a whole lake creel in 2017. So Ontario will have clerks on their side. We'll have clerks on our side. We'll be able to get a whole lake creel estimate, which is a really, really unique opportunity to be able to take advantage of. So with that, I'm going to hand it over to Jan for the fishery status update.
Thanks, Todd. Can you guys hear me okay in the back? Yeah. Great. So I'm just going to start with a little overview, and then we'll go through a couple of different sport fish opportunities and talk about how they're doing based on our assessments, and then sort of what we see for them. So, Phytoplankton creel, as Todd mentioned, it was in the American waters only, so the numbers that I'm giving you from the creel are only referring to about a third of the total weight. But in that estimate, we have 550,000 angler hours, and again, that's estimated from the counts and boats from planes to trailers. There are over 630,000 fish captured in yellow perch, smallmouth bass, and largemouth bass, and the top species. We had 117,000 fish harvested, and not surprisingly, yellow perch, walleye, and bluegill with a numerically dominant there. Here's a look at the total catch by species. So we have number of fish caught on the y-axis and different species groups there. Sort of a visual application of sort of the differences in numbers of fish caught on one species and yellow perch. Smallmouth and largemouth bass at the top, and then it drops off to from there. In terms of the number of fish harvested, again, yellow perch, and then at a much lower level, walleye, bluegill, and remaining fish species. So lots of harvest in yellow perch relative to the other species. So now, I'm going to go, and then this is the total fishing effort. So in purple here, let's see, there's the, okay, in purple here, this is this past year, and then these other lines are from the 2002, 3, and 4, because the ways that we conducted. So it appears that there was a pretty substantial drop in fishing effort between this past year's field survey and the field surveys that were done then. Measuring effort is really difficult on Lake St. Clair because there's a lot of boats out there and only a small fraction of them are fishing. So there's a lot of noise that has to be taken into account. So that's one thing that we work really hard at, is doing good estimates of how much fishing effort is happening. But this effort is increased during those earlier surveys. So now I'm going to go through some of the individual species themselves. So starting with our panfish, the y-axis here is the total number of fish captured, and the colors breaking into the number of fish released and the number of fish harvested. So for bluegill, about a third of all fish captured are harvested. Not many rock bass are harvested relative to the full number of catch.
That's a shame.
Pumpkin seeds have sort of similar ratios to bluegill, and then for crappie, about half of the fish that are captured are harvested, but a smaller number are captured. As Todd mentioned, we had a year-short survey that allowed us to actually collect some data on these fish species. So I'm showing you size length frequencies. So on the x-axis are all these fish groups, and then the number of fish that we caught in that year-short survey. So this is a snapshot over a couple of days. So it's going to be great about the survey moving forward is we'll have these length frequencies to compare from year to year. So we'll be able to detect whether or not changes are occurring in the size of fish. But for all of these camfish species, we're pretty happy. We have lots of young fish captured in the bluegill, but also some really nice size bluegill. Same thing with crappie, plenty of large fish that are yeah.
Are those captured with hook and line or with
These
nets?
are from electric fish.
Okay.
Yep. So good distribution of crappie and also lots of nice large pumpkin available. So we'll be able to track these changes in size, frequency over time, and have a really good sense of how these fish populations are performing. But we got really nice things in our pictures. So didn't have much room to leave the scale in there to show you the length, but lots of these fish are available in the fall, late October and November. So moving on to black bass and largemouth bass and smallmouth bass, here's a graph of estimated catch per efforts and how many bass are being caught per hour by anglers. And this is an average of all anglers, so not just people targeting bass. We take the total number of fish caught and divide it by the total number of hours fishing related to that. So here's catch per effort from 2003 and 4, and it's pretty consistent. We saw a large jump in smallmouth bass catch per effort, which is roughly double the catch per effort that we had in the earlier field survey, and correspondingly large jump in catch per effort for largemouth bass. The other day, we got a question about how the charter boat captains were doing and whether or not their numbers were sort of consistent with the field survey in general. And unfortunately, our charter reporting data doesn't go back far enough to directly compare with those field surveys. So basically, there's been a slight increase over our time series since 2010. Maybe a couple of years of lower catch relative to 2013, but overall, there's no significant relationship between year and charter catch. So, statistically speaking, charter catch has been flat over this time series. So, what is interesting is the total number of trips, which are shown here in red, and are on this alternative y-axis, have been increasing over the time. So, catch rates are staying more or less the same, while the number of trips being fished are increasing. So, that again shows a pretty robust and resilient fishery on catch rates. We looked at smallmouth bass size structure. So this is from that tagging work that Todd was talking about in the spring. We're targeting specifically adults that are staging to spawn, so that's why we don't see very many small fish. But we had a really nice distribution of the larger fish that average length was 17 inches. And we're targeting all fish, so not just the big ones where we have to see very few small fish. So again, one of the things that we're looking for here is a big drop off in size or the number of large fish above the legal harvest limit here at 14 inches. And we don't see that, so that suggests that harvest is not impacting the fishery. There's a lot of fish that are above that legal limit that could be captured. You get a similar view from the age structure. So if you take spines from these smallmouth bass and age them, so you get an individual up to 13 years old, lots of individuals in the 5, 6, 7-year-old range. So this is again indicative of a healthy population, lots of goldfish that can contribute to the fishery moving forward and get big enough, live long enough to get to a larger size. The 5 to 6-year-olds are probably getting into your 16, 17 range here. So these are the same fish, length and then the first one. Probably 3-ish. Does that seem about right to you guys? But the folks who've been on the system. So yeah, about 3 years. this is an estimate of total smallmouth bass mortality rate. So basically what this is the total number of fish that die, the percent of the population that we expect to die or leave the system in a given year. And as you can see, this blue line here is the actual estimate, and then this red line above and below are the confidence around that estimate. So with 95% certainty in a given year, we can say that the mortality rate is somewhere in between those two lines. And basically what this shows is that either a general decline in smallmouth bass mortality, or at worst a stable mortality rate. So there hasn't been an increase on smallmouth bass mortality in the system over this time. So again, that's a good sign. That means that the fish are doing very well. If you look at recruitment, what I have here is a recruitment score on the y-axis. This is 0 is an average year. So if you're above 0, that's a good year, and if you're below 0, that's worse than average year. And what we see is that recruitment has been pretty stable. So this blue is from our Michigan fall surveys. This dotted line comes from the Ontario same surveys that Todd talked about earlier. And what we see is that in general, it's pretty stable. There's been a couple of really good years, but there's been no really bad years over this time series. And the reason I show the Ontario data is because, you guys see that box at all? That was when the new spring catch release season started, but that regulation change only affected Michigan water. So overall, the Ontario data looks similar to the Michigan data, and so that suggests that regulation hasn't been affecting that our catch release season regulation hasn't been affecting the recruitment on the whole. If it had been, we would expect to see a divergence between the Michigan and Ontario data. And there is year-to-year variation, but there isn't a clear pattern of difference between those two data sets. So that's one of the ways that we kind of monitor the effects of regulation changes on the population. Looking at the largemouth bass, we don't have as much data about them. They again typically exist in the near-shore areas where we previously haven't done a good job sampling because of our limitations of being able to access that water that's less than 10 feet deep. This is again from our near-shore survey this fall of electric fishing. Because in the fall we're not bringing this fish quantity, so we see a large number of young of year recruits. We also have a couple of different age classes and lots of fish again above that 14-inch median length. In heavily exploited populations, you do see a very abrupt break at the legal size limit. So the fact that we don't have that there is again a good sign in terms of the abundance of these fish. And again, fish up to 18 inches is where we don't get a nice quality size of mouth bass. So moving on to pike and muskie. I played a little trick on you here to make the bars bigger. I put the axis on the log scale, so now the difference between this line and this line is 1/10 of the difference between this line and this line. So it just is to sort of emphasize the difference in the catch rates, but we've seen slight increases in pike and muskie catches compared to the previous field survey. So again, this is fish per hour. And again, this is an average of all anglers. So I'm sure the muskie and pike guys are doing much better on average than this. So this is the total effort in the lake, or the total catch in the lake. So unfortunately, we don't have too much more data. I am working on a muskie telemetry study which will help kind of explain how muskie are moving through the system, and we've had some really interesting results about that, which I can share with you at another time. But, yeah, good catches of these fish in the system. In terms of perch and walleye, we've seen pretty steep declines compared to the previous field survey. So here's yellow perch and walleye. Sharp declines, you can see yellow perch size structure from the fall of the survey shows a stepwise decrease, and so it's the perch are reaching harvestable sizes that are moving through the system pretty quickly. We know that there's a lot of perch in the system, and that tends to be seasonal, but a lot of the perch that we have tend to be pretty small. So we've detected a decrease in yellow perch growth. So this figure shows the state average here in this little blue line. This purple line or pink line shows what the growth of yellow perch in Lake St. Clair goes in 1995. You can see in 2008 it had dropped off from that and was about state average, and then in 2015 it fallen even further. So the perch that we have are growing more slowly. We're not exactly sure what is causing this, but it's a problem we're actively working on, and we're hoping to get an answer as soon as possible. These are the changes. So we're working on that. In terms of walleye, I have good news. We've had two really big year classes in Lake Erie, which tend to drive the amount of fish in the system. So the 2003 year class was a huge year class that drove the fisheries for over a decade. It's still influencing the catch of fish. The 2015 year class was the fourth biggest year class on record, and the 2014 was also a really strong year class. So those strong year classes are going to be pushing through the system for a long time. Last year there were a lot of fish that were caught that were just below the legal harvest limit. Those fish are going to be harvestable this year, and we expect them to continue to drive the fishery for several years moving forward. So for walleye, that's good news. The catch rate should be jumping up further. So we're encouraged with that. The other thing that we want to add is that we're trying to get a better handle of how the lake warms up and temperature, water temperature, because that's such a critical driver of fish habitat. So we've got some temp loggers courtesy of USGS, and we're going to be deploying those out in the lake here very soon, and that'll give us a really good sense moving forward of how water temperature changes in the lake and how that may be driving fish habitat use. I think that's all I've got. Here's my email address, or Todd's much easier to write down email address. Any questions that you may have. But yeah, we always welcome anger comments. We always welcome your observations, and we're right down there at the end of the South River Road, and we'll be happy to take your questions. Todd can answer your questions. So thanks a lot. The birds are a potential issue. I can't say that that increase in beef to harvest because we only have 1 year of data, but it's just that the fact that there's not many fish above, almost no fish moving to 9 inches and very few to 10, so that's not what we'd like to see in terms of the bird population. It's too early from 1 year of data to assign any causal effects, but there's probably a whole bunch of factors, both environmental, such as predation of various species and food chain or food web disruptions that we're trying to work these out. So it's going to be a major focus of our research on this. Mike shaking his head. That's not happening.
The Walpole Reservation, they do have
yeah, there's a proposed regulation change that's in the comment page right now. Is that what that's going to Todd?
Yeah, so our fisheries managers are the ones that are in charge of the regulation sides of things, and there's been a statewide proposal that came through the Warm Water Resources Steering Committee to have catch and immediate release for muskies year-round. That's being vetted right now for comments at our Citizens Advisor committee meetings. We just had one earlier this week. If you have comments on that, I would send those to our unit manager, Sarah Thomas, or our basin coordinator, Jim Francis. If you want to contact Jan or I by email, we can get you their contact info so you can share your comments with them.
Does the Creel survey cover the ice fishery too?
It did not, no. It's open water, which this year probably wouldn't have affected our numbers very much, but certainly in the past, we've had a big impact.
Have you guys started discussing possible management changes with the yellow perch if it does continue to show a decrease in size? structure in the lake of changing limits or doing something to manage the population to protect the larger fish?
My knowledge of those discussions haven't started. We are, we're working on trying to figure out the source of the problem. It may be that it has, little to do with harvest or, so we're trying to vet out the problem more completely, but certainly management is an option if you feel that that can help. All right, well, thanks a lot, guys. Like I said, don't hesitate to contact us. Yeah.
Our organization, who's the young lady from that did the presentation on sturgeon and stuff?
I think it's Toledo University, and she was part of USGS.
USGS?
Yeah, they do all the federal work.
So cormorants are migratory bird species, so they're managed at the federal level. I know that there's been some changes to the management as a result of some court injunctions that occurred, so the legal control that had been impacted was halted due to court order. I'm not really that familiar with too much else. I know they do harassment. They have still some non-lethal means of
Right, so one of the islands right by Mackinac is a big nesting place, and they were going on oiling eggs. So, I mean,
I'm pretty sure that stopped. Yeah, so I mean, it's sort of it's very little that we can do at the DNR because of their migratory status. It's certainly a challenge, but we're hoping that that'll kind of work its way out in the courts and we can move forward with. All right. Thank you guys once again. Really appreciate your time.